किसी ने खूब कहा है कि मेहनत इतनी खामोशी से करो कि कामयाबी आपकी शोर मचा दे। आज का लेक्चर इसी विचार के साथ शुरू करते हैं गाइस। दिस इज केमिस्ट्री बाइट्स और आज का टॉपिक है मोल कंसेप्ट, जो कि फिजिकल केमिस्ट्री का पहला और फाउंडेशन बिल्डिंग टॉपिक है। अगर आप फिलहाल क्लास 9, 10th या 11th में पढ़ते हैं और फ्यूचर में जेई क्रैक करना चाहते हैं, सो दिस लेक्चर इज अ वेरी गुड स्टार्टिंग पॉइंट फॉर यू गाइस। सो आज के वीडियो में हम कवर करेंगे 3 टॉपिक्स, वो है एटॉमिक नंबर एंड मास, आइसोटोप्स एंड डाल्टन एटॉमिक थ्योरी। और अगर आपको एलिमेंट्स, एटम्स, बेसिक स्ट्रक्चर ऑफ एटम्स, इलेक्ट्रॉन, प्रोटॉन, न्यूट्रॉन के बारे में नॉलेज है तो ये वीडियो समझने में आपको काफ़ी आसानी होगी। और अगर आपको इन चीज़ों का आइडिया नहीं है तो बेटर होगा कि आप इनके बारे में थोड़ा पढ़ लीजिए। तो सबसे पहला टॉपिक है एटॉमिक नंबर एंड मास। जैसा आप में से बहुत लोगों को पहले से पता ही होगा, दुनिया में जितनी भी चीज़ें होती हैं वो बनी होती हैं एलिमेंट्स से, और एलिमेंट्स इन टर्न बने होते हैं एटम्स एंड मॉलिक्यूल्स से। एटम्स एंड मॉलिक्यूल्स क्या होते हैं इनके बारे में हम इस लेक्चर में कवर नहीं करेंगे। ये जो टॉपिक है वो है एटॉमिक नंबर एंड मास का। अभी के लिए इतना बहुत है कि एलिमेंट्स एटम से बने होते हैं और हम सिर्फ एटम्स के बारे में बात करेंगे। अगर एलिमेंट्स का हम एग्जांपल लें तो आपको पता होगा हाइड्रोजन, ऑक्सीजन, कार्बन, आयरन, ये सारे एग्जांपल्स होते हैं एलिमेंट्स के। एलिमेंट्स जो बने होते हैं वो बने होते हैं एटम्स से। एटम्स के 3 मेजर कॉन्स्टिट्यूएंट्स हैं, इलेक्ट्रॉन जो कि नेगेटिवली चार्ज होता है, प्रोटॉन जो कि पॉजिटिवली चार्ज होता है, एंड न्यूट्रॉन जिसमें कोई भी चार्ज नहीं होता। अगर एटम का एक बेसिक स्ट्रक्चर देखें तो एटम के सेंटर में प्रोटॉन एंड न्यूट्रॉन एकदम सेंटर में कॉन्सेंट्रेटेड होते हैं, एंड इलेक्ट्रॉन्स जो है वो इस सेंटर के अराउंड रिवॉल्व कर रहे होते हैं। So before we learn about atomic number and mass, let's see what are the individual weights of electron, proton and neutron, because इन्हीं से डिटरमाइन होता है एक एटम का atomic mass. So an electron weighs 9 into 10 raised to minus 31 kg. प्रोटॉन एंड न्यूट्रॉन का वेट सिमिलर होता है, दैट इज अराउंड 1.6 into 10 raised to minus 27 kg. सो अगर इन दोनों का रेशियो देखा जाए तो a proton is approximately 1837 times more heavier than an electron. इसका ये मतलब होता है कि एटॉमिक मास में इलेक्ट्रॉन के मास का कोई बहुत ज़्यादा रेलेवेंस नहीं होता है। इट्स वेरी मिनिस्क्यूल एज कंपेयर टू प्रोटॉन्स एंड न्यूट्रॉन्स। इसीलिए एटॉमिक मास में प्रोटॉन्स एंड न्यूट्रॉन्स को ही कंसिडर करते हैं। ये सब सीखने के बाद हम आते हैं अपने सबसे पहले डेफिनेशन पे, और वो होगा एटॉमिक नंबर का। एटॉमिक नंबर इज डिनोटेड बाय Z, एंड एटॉमिक नंबर का डेफिनेशन है काउंट ऑफ प्रोटॉन्स इन एन एटम। अ लॉट ऑफ यू विल आर्ग्यू कि एक स्टेबल एटम में काउंट ऑफ प्रोटॉन्स या नंबर ऑफ प्रोटॉन्स is equals to number of electrons. So why not say कि atomic number is basically number of electrons, but this is a wrong concept, because if you take out one electron from an atom तो वो atom positively charged हो जाएगा। if you add one electron to an atom तो वो negatively charged हो जाएगा। but if you do the same with an atom using a proton, मतलब अगर आप एक एटम से अगर आप एक प्रोटॉन निकाल लेते हैं तो वो पूरा एलिमेंट ही चेंज हो जाता है। दैट इज वाई एटॉमिक नंबर ओनली डिपेंड्स ऑन द नंबर और काउंट ऑफ प्रोटॉन्स एंड नॉट ऑन द काउंट ऑफ इलेक्ट्रॉन्स। ऑल्सो प्रोटॉन्स एंड इलेक्ट्रॉन्स टुगेदर, these are responsible for the definition of chemical properties of an element, and this includes both proton and an electron. Let's quickly take few elements as an example to see how many protons do they have. For example, hydrogen has 1 proton, carbon has 6 protons, hence hydrogen's atomic number is 1, hence carbon's atomic number is 6, which is the Z. Let's move on to the another notation, n. N refers to the number of neutrons. Number of neutrons in an atom. As you know, neutrons do not play any role in defining the chemical properties. Number of neutrons do not change the chemical properties of an element. Neutrons only participate in atomic mass, and they do not impact atomic number, or they do not impact chemical properties. And together, let's finally come to the main atomic mass, which is denoted by A. A is nothing but atomic number, which is the count of protons, and number of neutrons, n. Z plus n. The sum of these two corresponds to A, which is the mass number. Now let's take few examples of elements and see what is the number of protons and neutrons in them, and what is their respective atomic number and mass number. For example, let's take the example of helium. Helium has 2 protons and 2 neutrons. So the mass number is 4 for helium. Oxygen. Oxygen has 8 protons, 8 neutrons. Mass number is 16. Let's take example of iron. Iron has 26 protons, 30 neutrons, hence mass number is 56. So I hope you guys understand, this is the atomic number Z. For helium it's 2, oxygen का 8 है, for iron Fe it is 26. Number of neutrons, which is the denoted by N. Helium has 2 neutrons, oxygen has 8, and iron has 30 neutrons. Hence, when you do the summation, you get the mass number. For example, iron 26 plus 30, 56. So 56 is the mass number for iron. It is not compulsory that number of protons and number of neutrons will be same. So let's see, using A and Z, how are the elements denoted. For example, oxygen. For oxygen, we just saw that oxygen has 8 protons and its mass number is 16. So let's say if you want to write any element X, the mass number is denoted on the top, A, and the atomic number is denoted at the bottom, this way. So for oxygen, you can write it as O, which is the symbol for oxygen. Mass number is 16 and atomic number is 8. For hydrogen, it will be 1 and 1. For iron, it will be 56 and 26. So this is how the denotation works. Let's talk about the importance of atomic number. So atomic number gives you an idea of number of protons and number of electrons. Since these stay the same for an atom, it gives you an idea of where does the atom lie in the periodic table just by looking at the number. आप नंबर देख के एक रफ एस्टिमेट लगा सकते हैं कि किस सेक्शन में होगा पीरियोडिक टेबल के ये एलिमेंट. एंड since periodic table is based on certain patterns, just by looking at the atomic number you can tell कि इस element का basic nature क्या होगा. For example, you can tell if it's a gas, if it's a metal, P block में है, S block में है. पीरियोडिक टेबल के ये आप एटॉमिक नंबर देख करके पता लगा सकते हैं. When it comes to mass number is mostly used in calculations where masses are involved. मतलब अगर आपको केमिकल रिएक्शंस करवाना है एंड यू वांट टू नो कि हाउ मच एलिमेंट यू नीड, दैट इन such cases mass number is helpful. Let's talk about another scenario. If you see the neutrons, they do not really impact the nature of chemical properties because it is mainly dependent on protons and electrons. There are few elements in which the number of neutrons is variable. So what you can know about them is that when you denote that element, the Z remains fixed for them, but A can change. That means that element can have a different number of neutrons in their atom and they can still remain stable. Such kind of cases are called isotopes, isotopes of a specific element. This is the next topic which we are going to talk about, the atoms of elements. That means the atomic number remains the same, but mass number changes. That means they have different count of neutrons. This is the key thing to remember when you're talking about isotopes. The number of protons remain the same, the number of neutrons are different. Hence, an element X might have the mass number changing. It could have A, B, C, different mass number, but the atomic number remains the same. So this is the basic definition of isotopes. Let's take an example to understand what are isotopes. Let's take example of carbon. Carbon has 6 protons. That's why I mentioned 6 as the atomic number for each of these atoms, but you can see the mass number is different for each. One has 12, one has 13, one has 14. So carbon is found in 3 forms in nature. One has 6 neutrons, one has 7 neutrons, and one has 8 neutrons. The abundance of these forms, मतलब कौन सा एलिमेंट कितना प्रेजेंट होगा नेचर में, इट डिपेंड्स अपॉन द स्टेबिलिटी ऑफ एटम. दैट इज स्लाइटली कॉम्प्लिकेटेड टॉपिक, बट यस इट डज नॉट मीन कि सारे के सारे फॉर्म्स आपको easily available होंगे. The most stable one is of course the most abundant. So in this case carbon 12 is 98.9% in nature, carbon 13 is just 1.1%, and carbon 14 is less than 0.0001% in nature. So this is an example of isotope. Now since we have established that there are 3 forms of carbon, there is no surety that when you take a piece of carbon you will be able to figure out what is the atomic mass for it, right? Because it can have any of these 3 forms. So we have a concept called average atomic mass. But before we move on to that, let's study another topic which is called isobars. So as you know, there is a carbon atom which exists in this configuration. It has 6 protons and 14 minus 6, 8 neutrons. So the total mass number is 14 for it. But if you see nitrogen has 7 protons and 7 neutrons. So the total mass number is 14. So as you can see, the atomic number for each element is always different. They can never be same, but the mass number can be same. This brings us to the topic of isobars. Isobars are basically atoms of 2 different elements. It's always 2 different elements. 2 or even more is also possible. 2 different elements. Since there are 2 different elements, they have different atomic number, but they have same mass number. It's because of the neutron distribution. Basically, number of protons and number of neutrons are not necessarily same. They can be more or less. Hence, we have such a thing. Now, before we understand average atomic mass, let's take an example. Oxygen. Oxygen always has 8 protons and 8 neutrons, so total 16. So whenever you take a big chunk of oxygen, pure oxygen, you can always be assured that each atom will have this exact same configuration. Hence, atomic mass of oxygen is always 16. Always. But we have just studied few elements which exist in the form of isotopes. For example, if you have carbon, as you know, it exists in three forms: C12, C13 and C14, each having atomic number 6. So when you take a chunk of carbon, you may not be sure that uh, what kind of atoms does it have, whether it has C12, C13 or C14, and hence you cannot determine the atomic mass of this whole chunk of carbon. Hence we use something called an average atomic mass. Average atomic mass is used so that we can find average atomic mass of elements which occur as isotopes in nature. Now how do we calculate is that we multiply the abundance by the atomic mass of that specific configuration and sum up all of these. So sometime back I had mentioned that C12 is 98.9% in nature, C13 is 1.1% and C14 is 0.0001%. That's all. So let's see how we can calculate average atomic mass for carbon. So for C12, the abundance is 98.9% and the weight is 12. For C13, the abundance is 1.1% and the weight is 13. And for C14, the abundance is 0.0001% into 14. Let's sum up all of these. So summing up these, now since these are in percent, we can mention it by 100. So the total comes out to be somewhere around 12.01 AMU. This is something called atomic mass unit. This is how we describe average atomic mass for elements which exist in nature in the form of isotopes. So the generic formula of average atomic mass is A1X1, which is where A1 is one of the forms of the element and X1 is its abundance divided plus A2 into X2, where A2 is another form of the element and X2 is its abundance divided by the summation of the total abundance. This is the formula for average atomic mass. So let's quickly go through a numerical question है. An ionic mass of X2 minus. X2 minus मतलब उस पे दो नेगेटिव चार्ज है. दो नेगेटिव चार्ज कैसे आ सकता है? प्रोटॉन निकाल के आ नहीं सकता, बिकॉज एलिमेंट से प्रोटॉन निकालोगे तो एलिमेंट ही चेंज हो जाएगा. तो बेसिकली नेगेटिव चार्ज लाने के लिए दो एक्स्ट्रा इलेक्ट्रॉन ऐड किए हुए हैं. सो आयनिक मास ऑफ X2 माइनस इज 16. अब इलेक्ट्रॉन कितने भी डालो मास नंबर पे फर्क नहीं पड़ता उसके, बिकॉज इट्स ओनली डिटरमाइंड बाय नंबर ऑफ प्रोटॉन्स एंड नंबर ऑफ न्यूट्रॉन्स. द क्वेश्चन इज get the number of protons, number of electrons and the atomic number Z if it has 8 neutrons. ठीक है, तो हमें मास नंबर A गिवन है 16, नंबर ऑफ न्यूट्रॉन्स गिवन है which is n, which is 8. So we had learned that A is equals to n plus Z, hence Z is A minus n, which is 16 minus 8, which is equals to 8. So Z, which is the atomic number, we have already gotten, that is 8. Atomic number is also the count of protons, the number of protons. So number of protons is also 8, atomic number is also 8, and now we have to calculate the number of electrons. अभी नंबर ऑफ इलेक्ट्रॉन्स निकालना है अपने को x2 माइनस में, मतलब देर इज अ 2 नेगेटिव चार्ज. इफ नंबर ऑफ इलेक्ट्रॉन्स एंड नंबर ऑफ प्रोटॉन्स आर सेम, तो फिर कोई भी चार्ज नहीं होगा, मतलब 8 प्रोटॉन्स एंड 8 इलेक्ट्रॉन्स, राइट. दीज टू बैलेंस ईच अदर, बट देर इज अ 2 माइनस, मतलब उसमें 2 इलेक्ट्रॉन्स और है, so that takes it to total of 10 electrons. So the number of electrons in x2 is 10. Let's quickly go through another question. Question है, calculate average atomic mass given. We have these 3 parameters. Isotope है 1H1 and 1H2. उनका abundance दिया हुआ 99.985% and 0.015%, और mass दिया हुआ है 1 and 2. Here we will directly apply the formula of A1x1 plus A2x2 divided by x1 plus x2. So let's do the calculation. 1 multiplied by 99.985 plus 2 multiplied by 0.01 divided by 99.985 plus 0.015. This totals to 100. So the answer to this is 1.00015 if you perform the calculation. So that's all for the numericals. If you guys are facing any doubts in any of the numericals which you guys are practicing offline, please put them in the comments. Coming to the last topic of the day, that is Dalton atomic theory. So Dalton was a scientist and he gave this theory in the year 1808. These are his observations. First observation is, all matter is made of very tiny particle called atoms. Atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. I think the second point, atoms are indivisible particles, that is something which did not hold true in the later times. Third, atoms of a given element are identical in mass and chemical properties. Atoms of different elements have different masses and chemical properties. Atoms combine in the ratio of small whole numbers to form compounds. इसका मतलब है कि whenever elements react, atoms are never broken down and reacted. Basically, it is not possible for 1.5 atoms of oxygen to react with 2 atoms of hydrogen. Any of such chemical reactions are not possible because atoms cannot be created or destroyed in a chemical reaction. That is what he meant by atoms combine in the ratio of small whole numbers. There is no concept of decimal. And the relative number and kind of atoms are constant in a given compound. So basically what he means is that if a compound has 2 elements and they are in ratio of 1:2, they will always be present in the ratio of 1:2. For example, the formula of water is always H2O. This honors 2 properties of Dalton's atomic theory. One is it combines in the ratio of small whole numbers, 2 and 1, right? And second, the number and kind of atoms. So water always has hydrogen and oxygen only, and they are always present in the ratio of 2:1. So you can say that at least some of the postulates and observations he gave, they were correct and they are still standing correct. Let's see what are the limitations of Dalton's atomic theory. First thing he mentioned was atoms are indivisible particles. What he meant was atoms are the smallest particles, uh, and you cannot further divide them. This does not hold true, because as of now we know that there are at least three main atomic particles: electron negatively charged, protons positively charged, and neutrons which are neutral in nature. There are other subatomic particles as well, but at least we know about these three, and hence atoms are not the smallest particles ever. Second, atoms of a given element are identical in mass and chemical properties. Chemical properties, yes. Mass, we have already seen isotopes. This is the second limitation. Third, atoms of same or different types have a strong tendency to combine together to form group of atoms, new group of atoms. For example, hydrogen, nitrogen, oxygen gases exist in nature as a group of two atoms. This indicates that the smallest unit capable of independent existence is not atom but a group of atoms. So basically, Dalton was not able to figure out the difference between atoms and molecules. Atom is the smallest uh, individual identifiable part of an element, but the stable existence of any element or a compound is a molecule. So this is something which Dalton's theory did not explain, nor he was able to clearly figure out why these things happen. So guys, this is the last topic. Next topic is going to be mole concept, but we will cover it in our next video. Please subscribe to my channel Chemistry Bytes. Drop all your doubts in the comments, or you can also DM me on Instagram. Thanks, and पढ़ाई करते रहो guys.